Hello everyone, for today's topic you're going to learn about alkenes. Please don't be confused between alkanes and alkenes. Last meeting we discussed about alkanes, which is carbon-carbon single bond. Alkenes, our discussion today, it is a carbon-carbon double bonds. So alkenes are another family of hydrocarbons. So what is hydrocarbons? I hope that you still remember. So hydrocarbons, it contains hydrogen and carbons. Okay, so let's have a short review first about our last topic about an alkane. So alkanes ends with A-N-E. So this is the general formula of an alkane. We have CN, H2N plus 2, where CN, N refers to the number of carbons, and then H2 it's a given. Then letter N here, it means, or it refers to the number of carbon plus number 2. So this is the formula of an alkanes. Again, CN H2N plus 2. For example, we have propane here. So propane having this three single bond of atoms or three single bond of carbon. So this is the structural formula, where 3 carbon atoms bonded with 3, 6, 8 hydrogen atoms. So as you can see here, how many number of carbons? We have 3 number of carbons. So C3, because letter N here, it refers to the number of carbons. And then just write H2 because H2 is given. Then N here is, again, N is refers to the number of carbons. So we have 3 number of carbons. So H2 times 3 plus 2. So that's why this is the structural formula of the propane, and the molecular formula is C3H8. For the formula of alkene, again, alkene ends with letter E-N-E. So the general formula for the alkene family is CnH2n only. No minus, no plus, no times. So just CnH2n, where N is equals to 3, 4, and so on. So alkenes are unsaturated hydrocarbons. Every alkene has a carbon-carbon double bond. So the difference between alkane and alkene having this single bond of carbon, while alkene having a double bond of carbon. The carbon-carbon double bond is the functional group for the alkene family. So the naming of alkenes follows the same IUPAC rules as used for the naming of alkanes. However, the presence and location of the carbon-carbon double bond must be indicated. So the name of a straight chain alkene consists of 2 component parts. So what are these 2 components? So we have the root part and the ending part. The root part denotes the longest carbon chain containing the double bond, and the ending part denotes the family name and the position of the double bond. So I will give you an example.
In this introduction to organic chemistry, you will learn the definition of a hydrocarbon and how functional groups give molecules similar properties. Organic chemistry is the study of carbon compounds. There are many millions of organic compounds that you can make using hydrogen and carbon and arranging them in different ways. Hydrocarbons are defined as compounds made of hydrogen and carbon only. The simplest hydrocarbon is methane. It consists of 1 carbon with 4 covalent bonds to hydrogen atoms. The next in the series has 2 carbon atoms, and this is called ethane, and is followed by propane and then butane, these being the names of the first 4 in the series of molecules called the alkanes. Pause this video now and try to draw the structure of hexane. Hexane has 6 carbon atoms. Here is the structure of hexane. Compare it to the structure you drew. Did you get it right? The next series is called the alkenes. These are hydrocarbons that contain a double covalent bond between two carbon atoms in the molecule. Just like the alkanes, each carbon atom still needs 4 bonds, but has 2 bonds already due to the double covalent bond with the other carbon atoms. The ethene molecule is completed by 2 more bonds with 2 hydrogen atoms for each of the carbon atoms. These also follow a pattern, and the next molecule in the series is propene and then butene. Pause this video now and try to draw the structure of hexine. As before, hexine has 6 carbon atoms. Here is the structure of hexine. This time there is a double bond because it's an alkene. The video tutorial on the alkanes and alkenes will give you more in-depth knowledge on the bonding and structure of these series of molecules. As we have already discussed, hydrocarbons are molecules containing only carbon and hydrogen atoms. However, the study of organic chemistry includes any molecule with a carbon backbone. Functional groups are groups of atoms which give molecules similar properties. There are many different functional groups. You may have heard of the alcohol group. This is a hydroxyl group and is a hydrogen bonded to an oxygen, which is then covalently bonded to the rest of the molecule. This group can be attached to any of the alkanes to form alcohols, their name all ending in -ol. For example, methanol, ethanol, and propanol. Pause this video now and try to work out the name of this molecule. There are 4 carbon atoms in this molecule with an alcohol group, and so its name is butanol. The alcohol functional group means that all these compounds will react in a similar way and will have similar properties. Carboxylic acids are another example of a functional group. This is the functional group for a carboxylic acid and gives an organic molecule the name oic acid. Methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. There are lots more functional groups. Esters, which give molecules a sweet smell and make them useful for perfumes and flavourings. Ketones, which make molecules useful as solvents. Amines, which can be used as dyes and useful in making medicines. Some molecules have more than one functional group and give molecules different properties still. Now, by the end of this video, you should know that organic chemistry is the study of carbon-based molecules, and that hydrocarbons are molecules containing hydrogen and carbon only. You should also know that functional groups are groups of atoms which give molecules similar properties.